Hi students, welcome back to the new session. In this video, we'll be discussing about how to find out the group and period of a respective element if it is given in the examination. How to find out the group and how to find out the period to which belongs to. So for example, in the examination point of view, if the element like magnesium is given, sir, magnesium is given, then how to find out this magnesium belongs to which group and which period means basic. If you should know about magnesium atomic number 12, its configuration is 1s2, 2s2, 2p6, 3s2. So its atomic number is 12. Its configuration is 1s2, 2s2, 2p6, 3s2. Now we need to think about the electrons present in the last shell. In this configuration, this is 1s2 means here n is equal to 1 means first shell. Here n is equal to 2 means these two comes under second shell. And here if we talk about in front of s orbital, we have, and here if we talk about in front of s orbital, we have 3. So this is n is equal to 3 value. Here n is equal, if I compare this configuration with NLX method, NLX, okay, here n is equal to how much? 3. So here n value is equal to 3. So the n value tells about to which period it belongs to. Period. The period number is 3, third period. And if you think about the electrons, 3s2, in 3s2 we have 2 electrons are there. In 3s we have 2 electrons are there. So these 2 electrons are present in which orbital? S orbital. So it belongs to S block. S block. So in the periodic table, we have a total of 4 blocks are there. So here is S block, here is D block, here is P block, and here is F block. Okay. So S block, this is P block, this is D block, and these are F block. So the electrons are in S orbital and the element comes under S block. If the electrons are in S orbital, the elements comes under S block. If the last electrons are in P orbital, the element comes under P block. If the last electrons are in D orbital, the elements comes under D block. If the last electrons are in F orbital, the elements comes under F block. So here we have 2 electrons are in S orbital. Hence, the element comes under S block. And we need to think about how many number of electrons are there. Only 2 electrons are there. So 2 electrons means it belongs to second A group. It belongs to second A group. That is third period. Third period. And the block is S block. And the group is second A group. It belongs to second A group. Now, I will explain one more example to this. One more example. We'll go with the example of oxygen. So, oxygen. Next element is oxygen. Oxygen belongs to which group, which period? So, element oxygen atomic number is 8. If you write the configuration, it is 1s2, 2s2, 2p4. So it belongs to 1s2, 2s2, 2p4 is the electronic configuration of oxygen. Now if you think about the last 2p4, 2s and 2p, 2s2, 2p4. So these two s and p orbital comes under same shell. That is, here is 2s2, 2p4 is there. Please concentrate on this particular concept. The orbitals only, no need to think about 1s2. So we have 2s2, 2p4. So here we have n value in both the cases. In 2s and 2p, n value is equal to 2. So it belongs to, so this n value, if n value is equal to 2, it comes under second period. So the elements comes under, this element comes under second period. And to which group it belongs to. Before writing about the group, we need to think about which orbital, in which orbital the last electrons are. So the last electrons are in which orbital? P orbital. If the last electrons are in P orbital, and the element belongs to p block. P block. Think about that, p block. And next one is total number of electrons. If I count these total of electrons, 2 plus 4, total how many electrons? 6 electrons are there. So 6 electrons means this element comes under 6th A group. Okay, 6 electrons are means 6th A group. 2 electrons are there means 2nd A group. 4 electrons are there means that is 4th A group. Understood? I will go with one more example to make you understand much clearly. And next one more, I will give the example of a higher element, that is, take the example of scandium. Scandium, atomic number is 21. You should know the atomic number. So scandium atomic number is 21. Its configuration is 1s2, 2s2, 2p6, 3s2, that is 3p6, 4s2, 3d1. 4s2, 3d1. So in this case, so we have to concentrate much on the last level of configurations. This 1s2 first shell, 2s2 2p6 comes under second shell, 3s2 3p6 third shell. And even sir, here we have 4s2 3d1. So think about this. Think about this. Here combination of these two configurations, that is 4s2 3d1. So among these two, which is having more n value means here is n is equal to 4 here n is equal to 3 only. So after filling 4s, the electron is going to enter into 3d. So here is n value become how much? 4. So hence it belongs to 4th period. In this case, you have to take among these two, which is having more n value. Oh, here n value is 4. Here n value is equal to 3. So n is equal to 4 means that is 4th period. Element belongs to 4th period, well and good. And next, think about the last electron is in which orbital? D orbital. So the last electron is in D orbital. It belongs to which block? D block. D block. And not only that, even how many electrons are there in these two together if I count? There is total number of electrons is 2 plus 1. How many? 3. So 2 plus 1, 3 means D block. In D block we have B group elements. All B groups are there. 2 plus 1, 3 electrons are there. It belongs to, total number of electrons is 3. It belongs to third B group. So scandium belongs to, the element scandium belongs to 4th period and third B group. Third B group. 4th period and third B group element is scandium. Now one more example, that is copper. Copper atomic number is 29. Okay, sometimes he might not be giving this atomic numbers. He may be giving the directly electronic configuration. So copper atomic number is 29. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. 4s2, 3d9. So it's very easy to identify. I think everybody understood this. 4s2, 3d9. So stable form of configuration of this one is we can write as 4s1, 3d10, half filled orbitals, last two. 4s2 is fully filled now. I will make it a half filled and I will promote one electron to 3d level. It will become 4s1, 3d10. So that is the configuration. Now by seeing this, either this or this, both are same. By seeing these configurations, we can able to know to which group or which period and this particular element belongs to. We need to think about it. So that is, if I count, common in these two is 4s1 3d10 or 4s2 3d9, anything you can take. So 4s1 3d10. Here among these two, which is having more n value, that is n is equal to 4, that is 4s1. And when is equal to 4 means it belongs to which period? 4th period. 4th period. And if you count, if you think about the electrons, last electrons are in which orbital? D orbital. So it belongs to D block. And if I count total number of electrons, 2 plus 9, if you count here, it is 11. Even if you count here, 1 plus 10, how much? 11. So it belongs to 11th column. So the 11th, the element belongs to 11th column in the periodic table, which comes under this is 11th column is a 1B group. 1B. Okay. D block elements contains only B groups and it belongs to the particular element copper belongs to first 1B group of the periodic table and the fourth period. Fourth period, first B, that is 1B group. Okay. Like this, you can solve the questions related to the elements, and if you are asking to identify to which group and which period the element belongs to. Sometimes he may give directly the configuration, and based on the configuration, he may ask you to identify to which group and period it belongs to. For example, I will go the example of fluorine. Simple example. Otherwise, you can go with the chlorine. So, chlorine. Configuration. I will write the configuration, then I will let you know. Example, a configuration of one element was given like this. The configuration given is 1s2, 2s2, 2p1. If the configuration is like this, it is asking to identify to which group and period it belongs to. So if you see common observation, if you see here both are having 2s2 is having 2, 2p1 is also 2. Last electron is in p orbital, and before p orbital we have is a 2, that is n is equal to 2, that is the second period. Second period, the element belongs to second period, and to which orbital it belongs to p orbital. Nothing but p in last electron is in p orbital, it belongs to p block. Remember that. And total number of electrons, if I count both the number of electrons here, 2 plus 1, how many? 3 electrons are there. In p block we have all A groups only. A groups. So 2 plus 1 how many? 3. That is, as you combine 2 plus 1, 2 plus 1 is equal to 3 electrons. It belongs to third A group. Okay. So based on configuration, you have to solve this particular question. Okay, this is a very, very important and somewhat a tricky question which is going to be asked in the board examination. Okay, thank you. I hope you everybody understood my explanation related to finding out the position of the element in the periodic table. This is a very simple technique and very, very simple trick to know. Okay, please, if you like my explanation, okay, like, share and subscribe and even comment in the comment section. Thank you.